Good afternoon, all of you. I am Kriti Manchanda, and I'm here to take your session for ratios and proportions. Today is the first day, and we are going to start with ratio chapter. So, ratio stands as the first chapter, and as in it is one of the first units, ratio proportion. Just quickly share my screen so that I can share the content also. हाँ जी Ratios in the ratio we try to analyze the relationship between two or more variables. So when we are talking about ratios in general, how many of us have related ratio in our day-to-day lives? So have you ever used ratio in the regular terms, as in say for example sometimes your marks are being compared to the others, like you got double the marks that your friend would have got, or very common usage of ratio when we see in our day-to-day life is whenever there is a comparison between men and women, whether it is in the form of results, whether it is in the form of voting, how many people voted, so these many number of men voted as against these many number of women. And like we compare the ages, the height, so many times your father might have told you, I'm double your age and you should respect, and like that. So yes, these are the typical scenarios where we are using ratios in our day-to-day life. So ratio, when we are talking about ratio in general, they are as in they identify the relationship between some values. They help us do comparisons between some values. So yes, so ratios are something which we can always relate in practical lives, something which do not require any particular formula, but it is more of your practical application in real life. So ratios are generally, expressed in the term as A is to B. Yeah. So ratios can be expressed as in the ratio A is to B, in the form A is to B. That's the standard way. That's the standard way of doing it. Whenever we are saying A is to B as a ratio, A represents as the numerator on the or the consequent, and B the numerator or the antecedent, and B represents the as the consequent. I'm really very sorry. Yeah, there was some technical glitch. Yeah. So we would be seeing all of this now into the PPT. Yes. So here we are. I hope this will be visible to everybody. So exactly this is what I was talking about. And I'm just showing. When I say ratio, I mean to say it is A by B, or we write it as A is to B. That is comparison between two variables. Say for example, if I say, if I have to make tea, how many tea leaves I should be, how much of the quantity of tea leaves I should be putting into my uh, water so that I have perfect taste or perfect blend of tea. So it shows sometimes comparison, like I told you, marks of boys is to marks of girls, or it sometimes shows relationship between two values. Say for example, uh, in 1 kilometer, if I say there are 1,000 meters, so 1:1,000. It shows the relationship between the two variables or the two values. So ratio are used for comparison. They are used as the relationship between two values. So when we are talking about ratios, it has terms A and B. They are terms to ratios, where A works as the first term and B works as the second term. The first term is known as antecedent and the second term is known as consequent. So this we would be hearing again and again when we would be doing, proportion chapter also. So whenever we are going to do comparisons and we're going to use properties of proportion, then antecedents and consequent would be the common term that you will be coming across. Yes. From here, we move further. So we have certain terminologies that we use for ratios. So the first term that we are using here is inverse ratio. Inverse ratio, as the name says, this is the inverse or reverse or reciprocal of a particular number. Why we are calling reciprocal? Basically, the definition of inverse ratio is that ratio which I multiply if with a given ratio will give me the product as 1. So what should be multiplied with the given ratio so that the ultimate product is 1? That will give me reverse. So for x, the reverse or the inverse ratio would be 1 upon x. Say for example, if I have the ratio 7:9 and I expect what is the inverse ratio out of it. So the inverse ratio would be, what should be multiplied by 7/9 so that we get 1. This 9 here, which is divided here, goes to the other side and becomes the product. So 1 into 9, and this comes as a denominator. So this becomes 9/7. So ideally, I should multiply 9/7 with 7/9 so that I get a product of 1. That is what an inverse ratio is known as. So very quickly, just revise. Let us just revise whatever we have learned till now. So if in this particular ratio says 7:9, I have to identify, I just talked about 3 terms here. 7 is antecedent, 9 is consequent. And inverse simply means interchanging the position of the 2 numbers. That is, antecedent becomes consequent and consequent becomes antecedent. So for again, if I have to give a generalized version, an inverse ratio means inverse ratio for A is to B means B is to A. That is, my antecedent becomes the consequent here, and the consequent here becomes the antecedent. The simplest way of understanding inverse ratio. So we can work it as in, mental maths also. So for 5/6, what would be my inverse ratio? It would be 6/5. For 7/10, it's 10/7. For 5, it's 1/5. As simple as that. So we are simply just finding the reverse or inverse of the number. Then another very important and very interesting concept is compounded ratio. So when I say compounded ratio, so supposedly I have been given 2 ratios, that is A by B and C by D. So compounded ratio is nothing but product of the ratios. So when I have to compound these two ratios, I would be multiplying the antecedents by multiplying the consequence. So it is simply product of all antecedents divided by product of all consequence. I hope this makes sense and this is interesting also. So let us use it again. So compounding means combining A by B and C by D, and these are the two different ratios. So for A by B and C by D, AC by BD is the compound ratio. So if my ratio is supposedly A by B, C by D, E by F, so what will be the compounding? A, C, E by B, D, F. Okay, so let's do some very quick questions. Let us say, for example, I have to find the compound of 5 by 6 and 7 by 8. So compound of 5 by 6 and 7 by 8 would be 5 into 7, 35, 6 into 8, 48. This is weak one. Another one, let's go for another one. What is the compound ratio of 3 by 7, 6 by 13 and 5 by 9? So let's go do it again. 3 by 7 into 6 by 13 into 5 by 9. Now here you can reduce them to the simplest form. So I can play this. 3 3s are 9, 3 2s are 10 here. So 10 upon 91 is my compound ratio. Yeah. This is how we are doing it. Okay. I think this is also doing good. Let's go for the next part, that is known as duplicate ratio. So when I have to do duplicate ratio, okay, this is a kind of extension of compound ratio. Kind of. When compound ratio says for A by B and C by D, the compounding is AC by BD. Duplicate ratio is nothing but compounding of ratio with itself. But this is only one time. In simple terms, A by B to be compounded with A by B again. So this becomes A square by B square, or in simple language we call it as the square of the ratio. So duplicate ratio is nothing but we are squaring the ratios. So very quickly let's try to answer these questions. So what is the duplicate of 10 by 13? I'm giving a few seconds for you to think about it. So before I write my answer, let's see. You people are doing the calculation. It's 100 upon 169. 10 tens are 100, 13 13s are 169. Again, what would be the duplicate ratio of 9 by 8? Again, giving you a few seconds. Try to solve it mentally. 9 9s are 81. 8 8s are 64. Let's do another one. Now this is interesting. 6 by 12. You have two ways of doing it. Simply compound it. 36 upon 144. Or then simplify it. Convert the ratio into simplest form. This is one of the basic rules of using ratios. You should be converting it into simplest form. So 36 fours are 140. The other way of doing it, 6 by 12 को we would be converting into simplest form first and then duplicating it. So 1 square is 1, 2 square is 4. So this is about duplicate ratio. Keeping the slide for your reference. Okay, so the next thing that we are going to talk about is subduplicate ratio. In the duplicate ratio, we do square. Subduplicate is going back. That is, we are going to do the square root. Or in other words, what ratio will give the given ratio as its duplicate. What I mean to say by this is, say for example, if I have a ratio called 9 by 16, 9 is to 16 is the ratio. Just correct. So, yeah. 9 by 16 is a given ratio. What ratio or what must be A by B whose duplicate is 9 by 16? So by answering this question of what is this A by B, you will be answering what is subduplicate of 9 by 16. So again, in simple terms, subduplicate means square root of the ratio. So subduplicate of 9 by 16 is square root of 9 is 3, 16 square root is 4. I hope this is answering. Let's try another one. Let's try to find out subduplicate of 576 by 729. You might be thinking, if the numbers are going to go bigger, how are we going to do? So you can use calculators, and all the simple calculators have the function of square root with them. So 576 square root is 24. 729 square root is 27. And if you are going to convert it in the simplest form, 3 8s are 3 9s. So 8 is to 9 is going to be the simplest form of subduplicate of 576 by 729. If we are thorough with duplicate and subduplicate, a related concept is triplicate and subtriplicate. Okay, we talk about triplicate here. Once again, triplicate ratio says compounding of ratio
itself, but thrice. Or A by B to be compounded with A by B again and with A by B again. In simple terms, it is Q of A and B. So that's a triplicate ratio. In simple terms, Q of the ratio. So let's quickly do some mental maths. Try to identify the triplicate of 2:3 and 2 for 3:7 also, and for 11:17. I hope we all have calculators ready with us. So when you're doing it in calculator, you have to multiply 2 thrice and 3 thrice. And when you do that, 2 as thrice would be 8. 3 multiplied thrice would be 27. So cube of 2:3 is 8:27. Cube of 3:7. 3's cube we just find out. 27 is to cube for 7. 7 sevens are 49. 49 sevens are 343. That's the answer. That's the answer. For 11:17. Now I hope we all are doing it very quickly on the calculators. 11 into 11 is 121. Into 11 is 1331. 17 into 17 into 17 times 4 will give you 4913. So keep checking the answers. I hope everybody is enjoying these questions. Next part is subtriplicate. Just like subduplicate, we have a subtriplicate also. So again, duplicate set square of the number. Subduplicate set square root of the ratio. We are here with triplicate, that is cube, and subtriplicate means cube root of the ratio. So we have to find the cube root of the ratio. So let me give you these simple ones. Try this. Calculate subtriplicate of 8 is to 125. 216 is to 343. And for 9261 is to 12167. So all set with your calculators? Let's see. Give us a quick answer. All right. Doing along with you. Cube root of 8. That is, what number will be multiplied 3 times so that I get 8. So subtriplicate of 8 is 2. For 125, it is 5. So subtriplicate of 8 is to 125 is 2 is to 5. Subtriplicate for 216 is to 343. So cube root of 216, or what number will be multiplied 3 times so that we get 216 is 6. 6 6 are 36, 6 are 216. What number do we multiply thrice so that we get 343? 7. We just did that calculation here. I hope you're enjoying this. Now again for 9261, 12167. Okay. Before, you might have tried definitely, and to give the answer also. But again, before going further, I would like to suggest you something for cube root, especially regarding cube root, how you can save your time in your exam also. Now, what you can do is, all of you must have this table ready with you. Or you must be knowing it, that 1's cube is 1, 2's cube is 8, 3's cube is 27, 4's cube is 4 4 is 16, 4 is 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 502, 9's cube is 729, and 10 cube is 1000. Why I'm telling you this? This helps you in identifying cube root on your calculators, because generally we don't have any function of cube root in the calculator. So this is one of the shortcuts that you can use in identifying what number I have to check. So especially if you get some big numbers like these, you would be trying each and every number to get 9261. How to get that 9261? No? So what you can do is check the last digit. Last digit is 1. Here it is 1. So that means the cube root of this cannot be first 1. You could try the cube of 11. You could try the cube of 21. You could try the cube of 31 and identify if 9261 is cube of which number. Same way, for the last digit ending with 7, that means the cube root must have 3 x units place. So the cube could be 3, could be 13, could be 23, and could be 33. Yeah? So just try, calculate. You would be finding cubes of these numbers. Whichever number fits in, that would be the cube root for 9261 and 12167. That's going to give you the answer. So yeah, that's the subtriplicate ratio. Okay. So further. Now you might be wondering, I've left this, yes, for all of us to try calculation. All right. Yeah. So the next thing that we are going to talk about here is certain more terminologies of ratios. One of them is continued ratio. So when we say continued ratio, like this is very important because often people confuse it with proportion. Continued ratios are different and proportions are different. So continued ratio would be when you can identify relationship between 3 or more of the variables. That is A, B, C are in some common relation with each other. Okay, so very common one that I can remember from your content, in fact from your syllabus, is you might have been studying about the accounting. partnership in accounting. And you might have heard, like, if A, B, C are partners in a firm and they agree to share profit and loss in the ratio 2:3:5. That's about continuity. Okay? Continued ratio. Like you have the relationship between three or more variables or three or more numbers which are of same kind, and you can represent them as a continuation in ratios. So it's not only about three. We can have for 5, we can have for 10, as many numbers or as many quantities that you want to compare, or you need to find out the relationship between. So that is known as continued ratio. We have some practical questions also about the continued ratio. So yeah, for A is to B is to C, continuation is this way. We represent it as this way. A is to B is to C. Again, supposedly I have three numbers, 20, 50 and 90. I have to represent it in the form of continued ratio. So ratios are expressed in the simplest form. So when I say 20 is to 50 is to 90, all of them are divisible by 10. So the continued ratio after dividing them by 10 would be 2 is to 5 is to 9. Very simple way of presenting it, isn't it? Okay, we can even do this with fractions. Say for example, if I have 4 by 3, 6 by 5 and 3 by 7, and I have to present it in the form of continued ratio. How would I do it? In order to represent this ratio in the continued form, there's a trick. The consequent of one ratio must be same as the antecedent of the other. Same for this. Consequent of one must be equal to the antecedent of the second. And with that, we can generate a continuate relationship between them. So if you have to present it in the continued form, how would we do it? As in, I will have to convert them. Only then they can be presented in the continued form. So this is 5 and this is 3. The LCM is 15. So I will multiply this entire equation, the entire ratio by 5 and this entire ratio by 3. So this is going to look like something this. 15 is to 35 and 18 is to 15. So these two quantities come in the continuation. Likewise, we would be trying to equate these two values also. So if this is 6, 3, say 18 and this is 3. So I will be multiplying the entire ratio with 6. So this becomes 24 by 18. Once again giving me the same number in the antecedent of one and the consequent of the other. Now I can combine and present this ratio as a continued ratio. So it looks something like this. 24 is to 18 is to 15 is to 35. Okay, that's how a continued ratio can be obtained. All right. So I'm giving you some time to absorb this. Okay. So the next thing we have is commensurable and incommensurable quantities. So when I'm talking about commensurable quantity, these are those quantities whose ratios can be expressed as the ratio of integer. Now, this is quite technical, you know, so, but this is a very simple concept. So if I say I have to compare the age of two boys in the class. So for one boy, supposedly the age is 10 years and the other boy's age is 11 years. So this is the ratio. And both the numbers are ratio of integers. Hence, this 10, 11 or age of boy 1, age of boy 2 are termed as commensurable quantities. Now you might be wondering what is incommensurable quantity. Supposedly, for some quantity which can be represented as so something which can be represented as square root of 3 is to square root of 5. So we clearly know that root 3 and root 5 are not integers, and hence these quantities are known as incommensurable quantities. Before going further, let's play a small game, kind of revision. So I'm just revising whatever terminologies we have used till now. We studied about, okay, no, of course, we'll start with the first one. We studied about the ratio A is to B. That is identifying the relationship between A and B or doing a comparison between A and B. So A and B are named as terms of ratio, where A is antecedent and B is consequent. That was the first thing we studied. The next concept that we studied was inverse of ratio or inverse ratio. For A is to B, its inverse ratio is B is to A. Then we talked about compound ratio. So for A is to B and C is to D, compound ratio is AC is to BD. In simple language, product of antecedent is to product of consequent. Then duplicate ratio. So for A is to B, its duplicate ratio is square of A is to B. That is A square is to B square. Subduplicate. Again, for A is to B, its subduplicate is square root of A is to square root of B. Triplicate ratio for A is to B, the triplicate ratio is AQ is to BQ. Subtriplicate ratio, again, for A is to B, subtriplicate is cube root of A is to cube root of B. Then we learned the concept of continued ratio, that is for any three or more quantities. The continued ratios are A is to B is to C is to D, okay? For as many number of quantities. That is a comparison of three or more quantities. And the last thing that we studied was commensurable quantity, as in those quantities whose ratio can be expressed as ratio of integers, and incommensurable quantities are the ones whose ratio are not integers, ratio of non-integers, that is incommensurable quantities. Alright, why I made you revise all of this is because now I would like to take up some good question, or let's play with numbers. Alright, try to calculate compound of A is to B, its inverse, its duplicate, its subduplicate, triplicate, and subtriplicate. Though it is going to be a very simple answer, but let's try this. So my ratio is A is to B. I have to compound it with its inverse, that is B by A, with its duplicate, A square by B square, with its subduplicate, square root of A by square root of B, its triplicate, A cube by B cube, and its subtriplicate, cube root of A is to cube root of B. If we do this, this is going to come to 1. This all gets cancelled out. For the rest of the values, so we are going to study about the indices, that is when the bases are same, powers are added. So we would be doing it in detail in the later chapters, but I can quickly tell you the answer for this. This is going to be 2 plus half plus 3 plus 1. Same for power. 2 plus half plus 3 plus 1. So when you solve this, that's going to be the answer. Okay, but this is not something which we are required to do as of now. Just play with numbers. Try to find the compound ratio of, I should ratio format. Find the compound ratio of 4:9 and subtriplicate for 27:8. It's like this, 4:9. Subtriplicate means cube root. So cube root of 27. 3 3s are 9, 3s are 27. So 3 is the cube root of 27. 2 is the cube root of 8. So when you multiply them, what do you get? Let's do it. 2 is 4 and 3 3s are 9. So 2:3 is the answer. That's the simpler one. Now, if you have gone through your study material, you have some more good questions. Something like this. What is the compound ratio of inverse of 10:13, duplicate of 2:3, triplicate of 3:5? Let's add some twist. Inverse of subduplicate of 49:100. It looks complicated, but when you break it into steps and solve it, this becomes very interesting, very easy calculation. So go one by one. I have to find out inverse of 10/13. That's 13/10. Compounding with duplicate of 2/3. Duplicate means squaring. So square of 2 is 4. Square of 3 is 9. Triplicating 3:5. Cube of 3 is 27 and cube of 5 is 125. Inverse of subduplicate of 49:100. So if I have to do subduplicate of 49:100, 49 square root is 7, 100 square root is 10. Now I have to inverse it. That means 10/7. Let's quickly get the answer. 9 3s are 27. 10/10 goes out. Anything else you can see that we can solve out of these? So I have 12 into 30, which is 156, and 135 into 7 is 875. So your answer is 156:875. Very good. Or, so giving you a few seconds, you want to note it down or try to grasp it. Okay, let's go to the other topic. I can go for the other part. We are done with the terminologies, and now we are going to talk about certain properties of ratios. So the first property of ratio, or the notes that we need to keep in mind. First one says that ratio must be expressed in lowest or simplest form. So like this is a general norm. It's a general rule that should be applied for all the ratios. Also, there is one more rule. Basically, it's an extension. It says for any given ratio, whether you multiply or divide, you should be doing it by same number multiply or divide by same number to keep ratio same. Okay, what does that mean? So if I have a ratio A is to B, in order to keep it as A is to B, if I have to supposedly multiply or double the quantity, so I would be doubling it on both antecedent as well as on consequent, so that I have the ratios. Okay. So for example, if I have 4 by 7 and my quantity is now 10 times, what should be done? 40 to 70. So those many of us who are into cooking stuff, so we know if I am doubling the number of cups of tea, the quantity of water for making the tea, I will have to double the sugar, I will have to double the tea leaves. So every quantity will be changed equally. So that is exactly what it means in general. Even if you have to increase by multiplying the quantity, so multiply the antecedent and the consequent by the same number so that your ratio remains intact. Even if it is required for dividing the numbers, say 100 upon 450. So for dividing also, you will use the same number in the numerator as well as in the denominator. So this becomes 10 is to 45, or again I can divide it further. So I would say by 5, by 5. So the simplest form of 100 by 450 is 2 is to 9. So it is better to present ratios in general in their simplest form. That's the first one. Alright, the other very important property of ratio is that the order of terms of ratios is very important, or the order must not be changed. Why so? What is order? If I have a particular ratio in A is to B order, you cannot say that A is to B is same as B is to A. It is not. That's wrong. A is to B can not in general be equal to B is to A. Only this rule is applied only for 1. Only 1 upon 1 will give you the same ratio with its inverse. Rest for all the numbers, it cannot be same. Just imagine 1 is to 2 means half, and just reverse the order, 2 is to 1. They are absolutely not same. 5 is to 2 is not same as 2 is to 5. So just keep the order of terms of ratios same always. One more thing I would like to tell you here. If A is to B is same as 2 is to 5, and you are required to change the order, you will change the order of this also. What I mean to say is, if you're changing the order for this, that is A by B is represented as B by A, this 2 by 5 should also be represented as 5 by 2. Only then this equation will remain true. As I told you, A by B is not equal to B by A. They are not equal. Clearly, even if you convert it into decimal, this is 2.5, this is 0.4, which is absolutely not equal. Just have a look at it before we go for the next slide. The next point says, very, very important one, no? Quantities must be of same kind. When you're expressing anything as a ratio is to B, the quantities must be of same kind. What I mean to say is, maybe you are comparing your height with your siblings' weight. Of course, there's no logic into it. That entire ratio or comparison is wrong, nullified. Yeah, you cannot compare two quantities which are not of same type. You may do this, that you're comparing your height with siblings' height. You may do that. My height is supposedly 165 centimeter and my elder sister is 160 centimeter. I can compare and I can say, yes, I'm taller. Or maybe I have an elder brother whose height is 180 centimeter. Oh my God, he is so far taller than me. So for comparison purpose, for identifying relationship between the two quantities, they must be of same kind. The next logical, I always call it as a logical. The next logical property is that quantities must be of same units. What I need to say by this is, I'm saying I took 5 hours in completing a chapter. I was learning a chapter and I took 5 hours. And you said, I took 18,000 seconds, I have done more hard work than you. So 5 is to 18,000? Oh, no, absolutely wrong. So the quantity units, that is hours or seconds, must be said. So either you convert this into seconds or you convert this into hours. So 5 hours can be expressed as 5 into 60 minutes into 60 seconds, which is 80,000 seconds. So I said, oh my God, I have studied equally. If you have studied for 18,000 hours, 18,000 seconds, so am I. Or my sibling says, I studied for 5 hours. You also studied for 5 hours. You studied equally. So your quantities must be in the same units. Someone said, my height is, again I'm going to height, okay. So not my, okay, I'll say Mr. A's height is 5 feet and 11 inches. Then Mr. B came in. He said, my height is 170 centimeter. No comparison, no ratio. Convert this into centimeter or this into feet. We then get compared. So just remember, When you're identifying relationship between certain quantities, they must be of same kind. Like I'm talking about height and height. I'm talking about time spent on studies. They must be of same kind as well as of same units. Now, another two very important properties that we need to know. It says comparison of ratios can be done by converting them in fractions. What is it? I say compare 4:5 with 1.5. 4:5 to be compared with 1.5 and tell me which is greater. The two numbers are represented in different forms, so you cannot compare it. So convert both of them in fractions or convert both of them in decimal. So for 4:5, I can write it in decimal as 0.8. Now I compare it with 1.5 and I know 1.5 is big. Or convert this 1.5 into fraction. Decimal gone, 10 here, 3/2. So one number is 4/5, the other number is 3/2. Again, how will I do the comparison? Because I have different denominators, it is not a simpler task to compare these two to compare these two ratios. So what should I do? Here comes the role of LCM. Make the denominators same and then compare the numbers. As in 3/2 can be multiplied with 5. I get 15/10. 4/5 to be multiplied with 2. I get 8/10. Now I can compare 15/10 with 8/10. And I know 15/10 is greater. Alright. So the next note is factor multiplying ratio. Now what is factor multiplying ratio? It says if a quantity increase or decrease in some ratio, and that ratio is A/B, then new quantity will be equal to inverse of that ratio multiplied with old quantity. That's factor multiplying ratio. So this B/A is nothing but factor multiplying ratio. So factor multiplying ratio is that ratio which must be multiplied with the original quantity to get the new quantity when that old quantity is changing in the ratio A/B. I'm sure you need some more explanation of further same. So we'll do it with an example. Now don't take it seriously on me. This may or may not be correct, but supposedly my weight is 75 kgs. And now I wish to reduce it in 5:3 ratio. What does it mean? First of all, we need to interpret this statement. If my current weight is 75 kgs, I want to reduce it and reach to maybe say X kgs of it. So that reduction will be in the form that 5 represents my current or the older weight, and 3 would be representing my new weight. That's how we are changing. So if you cross multiply and do it, something like this. How much should I, reduce as my weight? So this 75 remains here. 3 here as a dividing factor comes and get multiplied here. 5 multiplying gets divided here. So it's like this. Isn't it the same formula that I was just now talking about? Factor multiplying ratio. It says your new quantity is equal to old quantity multiplied with the inverse of ratio. Exactly, this is what we are doing. So what is my new target ratio? I hope now all of us might have got my new weight, which is next to impossible for me to reach. So 75 into 3 by 5 is 45 kgs. I don't even want to get that lean. That's one way of doing it. I can even tell you the other way. Let me try to understand it the other way. So, okay. So I'll tell you the other way, the alternate way of understanding it. When I say I have to increase or decrease a quantity in certain ratio, that is in A is to B. So if I wanted to decrease it in the ratio A is to B, wherein 5 represents my present weight and 3 represents my future weight. So right now I'm 5 times and I need to come down to 3 times. So 5 times or 5x is the current weight. 5 times x ले लिया. So I have 5 times x to be equal to 75. So x, that factor comes to 50. And I want to come to 3x. So hence my new weight would be 45 kgs. So anyways, that is factor multiplying ratio. Now we are in a good position to practice some questions. Half an hour left to go, and let's practice a few questions. I told you ratios are more commonly used for comparison between genders, male and female, boys and girls. The results when they pass out, generally they are represented as the 10th board or the 12th board. They are represented this way. How many girls overpassed boys' performance? Generally, it happens this way. So the question number 1 says, ratio of male and female employees in an office's office of 500 people is 3:2. If 10 new female employees join the office, how many more male employees must be joining so that the new ratio comes to 5:3? So I'm giving you a few seconds to try for yourself, and then I'll solve it for you. See, there is no hard and fast rule or format of solving any ratio question. It's more of logical understanding, the way you understand it. So you can apply that, methodology for yourself. It can be using a formula. If you understand by using X and Y, you can do it that ways. So we have multiple ways of solving any question. I'll just quickly take with you. Let's do it. So this question says total employees are 500. The male and the female ratio is 3:2. Let's divide. 3:2 means 3 by 3 plus 2 would be the total. If 3 is the male, 2 is female, so the total will be 3 plus 2. So 3 upon 3 plus 2 of 500 will give me the male members. 2 upon 3 plus 2 will give me, or 500 will give me female members. So the male members are 300, female members are 200. This is the existing situation. Now we have new people entered in the organization and hence 10 new female employees joined. Means 210 is a new number for female. How many more employees, male employees must join so that the ratio between these two becomes 5:3? As I'm telling you, there are a number of ways. So the first one that I personally use, that's a common, or my understanding how I go with it is, the ratio must be 5:3. Female employees are 210. 3 into 70 gives me 210. And this is what I learned in ratio, that whatever number you are multiplying with the consequent must be the same number that you are multiplying with the antecedent, so that ratio remains same. So if 3 to be multiplied with 70 to get to 10, 5 can be multiplied with 70, and the new number of male employees are 350. This is a total male employees, out of which, so 350 are total male employees, 300 are existing one. So how many more? I need 15 new male employees. That's what we are doing. Okay, I can do it at the other way. So if I have the ratio of 500 people as 3:2, I say male employees be 3x and female employees be 2x. So this 3x plus 2x forms 500. 5x is 500 and hence x is 100. Hence, my male employees are 3 into 100, 300, and female employees are 2 into 100, 200. This is the existing scenario. Now, what number of male employees must be added? So I say let Y be number of male employees added. So in 300, I'm adding Y. The new female number is 210. Already given to me, 10 new female entered. So now the ratio becomes 5:3. Cross multiply, solve for Y, and you get the answer. So it is 3 into 300, 900 plus 3Y, same as 1050. So 3Y is equal to 1050 minus 900, that is 150, and Y hence is equal to 50. Exactly, this is what we got from here. Yeah. So these are just two examples. You can use any ways, any method that you understand, but you just have to ensure that the required ratio is met. Let's go for the second question. Okay. Let me just wait for a few seconds. This is the second question. And this is very easy one. It says the ratio of two quantities is 5:9. If the consequent is 8:10, what is antecedent? I told you that we are representing ratios in simplest form. So 5:9 is the simplest form. So you may do it this way. The quantities be 5x and 9x. So 5x by 9x is 810. What is this? You have to calculate. So basically you have to identify what is this x. So playing with number again. Sorry. This is 810 and I have to find this. So what would I do? What should be multiplied with 9 so that I get 110? 810. 9 nines are 81. So 9 multiplied with 90 gives me 810. Same here. Multiply with 90 and you get your answer. As simple as that. So what is the antecedent? It's 450. Again, one way of doing it. I'm sure by now you would be able to figure out the other way also. So I say 5:9 is same as, I don't know what is antecedent, by 810. Simply cross multiply. 5 into 810 by 9 gives me the antecedent. So antecedent is 450. You can do any of the methods. Third question. So the question says the ratio compounded of inverse of 7/5, duplicate of 1/3, and subtriplicate of 343 is to 512 is We have already done these types of questions. So inverse of 7:5, that is 7. Duplicate of 1/3, 1/9. Subtriplicate of 343 is 7. 5 and 2 is 8. And you have to compound them. So you multiply. So with 7, the 7 is gone. 5 is to 72. This is. The next question. Ratio of, now these are some application type questions. Ratio of price of bat and ball is 7:3. That is, price of bat on price of ball is 7:3. Then the ratio of price of hockey stick and price of ball. Price of stick, ball, price of ball is 7:2. We have to find the ratio of bat and hockey stick. So I have to find the ratio of price of bat, price of hockey stick. Okay, for representation purpose, I'm writing bat as BA, ball as BL, hockey stick as HS, ball as B. So now I have to find out the relationship between bat price and hockey stick price. Can I do this? Not yet, because price of ball here is in the third ratio. Here it is in the second ratio. Had these two been equal, then there wouldn't have been problem. We could have directly, used the ratio between these two. But right now the problem is that the denominator or the common variable between these, other variables is giving different quantity in two different ratios. So what I need to do is I have to bring them to a common number. So I say bat by ball and 3 and 2, I'll take LCM as 6. So the ratio price of bat and ball can be expressed in terms of 6 would be 14 upon 6. Likewise, ratio of price of hockey stick and that of ball is 21:6. I have to find, now I can compare it. See, the ball price here is also 6 and here it is also 6. So now I can compare these two. So I say ratio of price of bat with that of hockey stick would be, if I divide this ratio with this ratio, see if I can get the answer. So these prices go off and I get this ratio. Yeah. So 14/6 into 6/21. So the ratio between the price of bat and the price of hockey stick is 14:21, or simplest form, remember? 7 2s are 7 2s are 62730. Let's start. Keeping the solution for you. Okay. Very quickly, let's go for the next one. It says A is to B is 3:5, and I have to find the value of this ratio. So if A is to B is 3:5, I have to find the value of this. Those who are good in algebra would be loving it. We use certain formulas here, algebraic formula. I take AB common out here. I have A plus B here. And A cube plus B cube can be represented as A plus B, A square minus AB plus B square. And you might be wondering what good it is going to do. A plus B gets cancelled out. Divide numerator and denominator by AB. So numerator, when it is divided by AB, makes it 1. Denominator, each term to be divided by AB. So this is 1 upon A by B minus 1 plus B by A. Now we are in a position to put our values. So it becomes 1 upon 3 by 5 plus 5 by 3 minus 1. I take the LCM. 15, this is 9 plus 25 minus 15. This one goes up and it looks like this. 15 upon 9 plus 25, 34 minus 15 is 19. So 15 is to 19 is your answer. Let's go quickly. We have some more questions before we wind up. All right. So it says Mr. X and his wife are earning in the ratio 2:3. Their expenses in the month are in the ratio 4:7. If both of them save 7,500 rupees per month, what is their monthly salary? So what we can do is, I say earnings of Mr. X and Y would be 2x and 3x. Expenses are 4y and 7y. Why I'm taking y as a different number? Because of course it's a different variable. So this is a different variable, earnings is a different variable, expenses is a different variable. In simple terms, when I subtract expenses from my earnings, the leftover amount is what I'm saving. So both of them, after expending their respective salaries, are able to save 7,500 per month. What are their salaries? So 2x minus 4y is 7,500. 3x minus 7y is 7,500. So if you are thorough with linear equation, you solve it by using any of the methods, cross multiplication, or you want to use substitution or elimination, whichever method, and you can get the value for x and y. If you want to do it with the ratio system, you can even do that. So I'll show you how I do it with the ratios. So what I would be doing is, both of them are equal to 7,500. So hence, 2x minus 4y is same as 3x minus 7y. Both are saving equal. So take x is on one side and y is on other side. So 3y is equal to x. My salary is 3 times my spending. You understand the logic also. So x by y is 3. This is what I got. Now I quickly take up any of the equation. And I say divide by y. This becomes 2x by y minus 4 equals to 7500 by y. So 2 into x by y is 3 minus 4 is equal to 7500 by y. 6 minus 4 is 2 and y comes here equals to 7500. Y is 3750. X, you know, x is 3 times 3750. That is 11,250. So the respective salaries, 2 into x, so the respective salary would be 2 into 11,250, that is 22,500, and 3 into 11,250, that is 33,750. Net salaries. Let's go for the next question also. Today we won't be in the position to take up your queries because of technical issues. Tomorrow onwards we'll have the normal query session. We'll take up your queries in the class. Even for today's topic, if you have any problem, we can discuss it tomorrow. All right, next question. So it says, if P is to Q is the subduplicate ratio of P minus X square is to Q minus X square, then what is X square? So I'll just write the equation, what the statement is saying. If P by Q is subduplicate of this ratio, that means is subduplicate of this ratio is P is to Q, and I have to solve for X square. So squaring on both sides, we get this as P square by Q square. This is P minus X square upon Q minus X square, and cross multiply quickly and solve for X square. When we will be done with the proportion chapter, I'll share the other way of doing it. But as of now, we'll just cross multiply and find the value. So this P square Q minus P square X square equals to PQ square minus Q square X square. So I'm just taking it here. All X squares on one side. So P square Q minus PQ square equals to P square X square minus Q square X square. Take out PQ common. P minus Q is equal to X square common. P square minus Q square. So X square is equal to PQ into P minus Q. This is multiplied here. Here when it comes is divided. It's this. Again I can use another algebraic formula here. A square minus B square is A minus B into A plus B. This comes off. So X square value is PQ upon A plus Q. Right? Just a couple of questions more. I do them quickly. It says the ratio of ages of father and son is 7:3 now. So father's age 7x and son's age 3x. 5 years ago, so 5 years ago, father would have been 7x minus 5. So if I am 10-year-old right now, 5 years ago I was 5 years. Or if I am 20 years right now, 5 years ago I was 15 years. So what I've done, I've simply deducted 5 years from the present age. And hence son's age is 3x minus 5. So 5 years ago, the ratio of their ages is 3:1. That's it. So, okay. So it says 3 into 3x minus 5. 7x minus 5 is equal to 9x minus 15. Solve. This goes here. So 2x is equal to 10 and x equals to 5. That gives me father's age as 7x, that is 7 into 5, 35. Son's age as 3x, 3 into 5, 15. And you can also verify. Go back 5 years ago. 5 years ago, father would be 30 years. Son would be 10 years. Isn't it in the ratio 3:1? That is what it said. I will tell you a few shortcuts also in the next class. Because you're going to attempt MCQ questions. In case of MCQ, sometimes even without solving, we can identify the answer. So I'll show you those tricks in the next class for sure. Okay, last two questions. In a competitive exam, the ratio of failing candidates to the total strength is 3:50. So if 50 people attempt, it is a sure proportion that 3 would fail. 47 will pass. So if in a particular given exam, number of candidates sat for exam at 20,000. So total candidates 20,000. It's very easy. How many fail? 3 out of 50 people fail. How many will fail out of 20,000? Or, as I told you, if 3 by 5, total is 20,000. You have to find this. 5 into 4,000 gives me 20,000. Into 4,000 will give you the number here. 4,000. Oh, sorry, it's 50. I'm so sorry. It's 50. Then 400. So 1,200 candidates will fail. This is the way of one of the ways of doing it. The other ways of doing it is you just solve this ratio and you get 1,200. That is also one of the ways. So 1,200 candidates would be failing. And if 1,200s are failing, how many would be passing? Out of 20,000, if 1,200 fail, if 18,800 are passing. You can even use X for doing this, like you can say 3x. but since it is as compared to the total strength, so let's not get into this. Okay, the last question, the easiest one. What must be added to both antecedent and consequent of 21 is to 37? So I have a ratio 21 is to 37. What must be added to both of them so that new ratio becomes 3 is to 5? Let x be added. When you have nothing in your solution, you have x. So 21 upon x, 27 plus 6, you get 3 by 5. Cross multiply 105 plus 5x is equal to 111 plus 3x. So 5x minus 3x is equal to 111 minus 105. That gives us 6 here and x is 3. And I do it, you know, not through x. I personally do it using that mental methods concept. So I have to convert it into 3s to 5. So immediately I must see what is the nearest 5-digit, the number which is divisible by 5. So that would be 40. So in order to reach 40, I have to add 3 here. I added 3 here. So that makes it 24. So 8 threes are and 8 fives are. That makes me 26. All right, that's it. Thank you very much. And as I told you, we can have the query session sometime in the next class, when we'll be out with the technical glitches. Your queries will be most helpful. Sir?